Okay, so today we're going to actually solve rational equations. This is section 8.6. This is kind of like the culmination of what we've been doing. We've added, subtracted, multiplied, and divided rational expressions, and now we're going to apply them in terms of equations. Um, this is going to be a two-part section. Here's part one, which just is going to walk through the basic equations, and then part two has to deal with more of the application problems for why we see these and where we would see them in the quote-unquote real world. Okay, so to start with, I want to warm up with a very, very simple rational equation. Okay, you have 1/4 plus 2/3 is equal to x over 5. Now, in looking at this, you might see, a couple fractions here, and you might try to just add these together and then end up multiplying by 5. Okay, and you can certainly do that. Okay, but I'm going to show you a process that is going to apply to these more difficult ones as we see down here. And that is to kind of get rid of all of the denominators. Now, whenever you're adding or subtracting multiple fractions together, you need a common denominator. Okay, so what you want to do here is look at all your denominators and you need to multiply by all of them combined. Okay, so 4 times 3 is 12 times 5 is 60. So you might say if we multiply everything in this equation by 60, all right, that's going to cancel out your denominators, which is actually your goal for this. But instead of writing it as times 60, I want you to leave them as individual factors. Okay, so 4 times 3 times 5. Okay, and we're multiplying them into all three of these terms. So if we rewrite what we have, okay, the 4 times 3 times 5 times the numerator 1, you would have just the 4 times 3 times 5, okay, over the original denominator 4. Okay, in the second fraction, you'd have the 2 that was already there, and then times your three numbers, 4 times 3 times 5, all over the original denominator 3. And then you have your original x times 4 times 3 times 5, and the last fraction over 5. Okay, so the reason why I showed you this way rather than just multiplying by the 60 was because now you can see that these 4's cancel, these 3's cancel, and the 5's cancel, and all of a sudden all of our denominators are gone, and if we look at what's left, we have just a basic linear equation. Okay, you have 3 times 5 from your first term, well that's 15. 2 times 4 times 5, well that's 40, is equal to 4 times 3 times x, which is 12x. All right, and look at that. That's a much easier equation to solve than what this looks like up here. Okay, well, 55 is equal to 12x, and you divide by 12, and x is equal to 55 twelfths, or 4 and 7 twelfths. Okay, so that's going to be kind of the process. As you see right here, your goal should be to cancel out all the denominators. And then, of course, we want to watch for restrictions because we're dealing with variables in the denominator. Okay, so that process of multiplying by all the factors in the denominator, that's what we want to do here. Okay, this is a more complicated one. X over x minus 3 plus x over x plus 3 equals 2 over x squared minus 9. Now, before you even do anything, simplify that. Okay, x squared minus 9, we should all know that's x plus 3 and x minus 3. That's difference of perfect squares. Okay, so I'm just going to rewrite that. And then also, before we do anything else, I mentioned up there, watch for restrictions. So right away, I'm going to say that x cannot equal, based on these denominators, it can't equal positive 3 or negative 3. I'm just going to set that off to the side for right now while I do the actual process. Okay, so now let's look at what the denominators are. X minus 3, x plus 3, and then you have both of them, x plus 3, x minus 3. Okay, so that's what we need to multiply by. To cancel them out, you need to multiply by both x plus 3 and x minus 3. Okay, so let's show those steps like we did up here. Okay, so on the first fraction, you have that original x, okay, times the x plus 3, x minus 3. Okay, and that's over the original denominator, x minus 3. Okay, that's the first fraction. Second fraction, you have your x that was already there times the x plus 3, x minus 3, over the original denominator, x plus 3. And that equals the original 2 times the x plus 3, x minus 3, over the original denominator that I've changed, x plus 3, x minus 3. Okay, I do that, I'm showing these steps to show you what cancels out and why it cancels out. All right, very easy to see. Okay, x minus 3 is gone, x plus 3 is gone, and actually both of them are gone. And now all of our denominators are gone, which is super, super nice. Okay, so rewrite what you have. Now you can go ahead and multiply here. You have x times the quantity x plus 3, distribute that, x squared plus 3x. Okay, you have x times the quantity x minus 3. Go ahead and distribute that x. So you have x squared minus 3x, and that equals 2. Okay, that's it. So then this is much easier to solve than what we saw up here, right? So if we combine our like terms, all right, the plus 3x minus 3x, those cancel out. So you're left with an x squared term plus another x squared term, which would be 2x squareds, is equal to 2. You divide by 2, you're left with x squared is equal to 1. And then remember when you take the square root in an equation that you get plus or minus. So x in this case would equal plus or minus 1. Now, the reason why I had to write the restrictions off to the side right away is so that we could now compare. And plus or minus 1 is not plus or minus 3, so these both work. So we're good to go. If we had a solution here that interfered with one of our restrictions, well, then that would be an extraneous solution. Okay? So multiply everything by your denominators so that the denominators cancel out. Okay? Don't worry, I'll do another one. Okay? So here is another one. Okay? Minus 1 over x squared plus 3x 2 plus 2x over x 2 equal to x minus 1 over x plus 1. Okay, again, let's factor this right away to see what we have. Okay, x squared plus 3x plus 2. Factors of 2 that add up to 3 are going to be 2 and 1. Okay, so get rid of that. Which you see x plus 2, x plus 1. This has the x plus 2. This is the x plus 1. So you only need to multiply. Okay, now if you see like x plus 2 and this has an x plus 2, okay, you see that? You don't need to multiply by them twice. You only need to multiply it by it once because there's only one of these to cancel out, right, in each term. So that's what you're going to be multiplying by, x plus 2 and x plus 1. Okay, so let's rewrite what we have. Original numerator, you had x minus 1. I'm going to write it in parentheses so I don't forget. Okay, times the two new factors, x plus 2, x plus 1, over my denominator, which was x plus 2, x plus 1. Okay, second fraction, the original numerator was 2x, so that's going to stay there, times our new terms that we're multiplying by, x plus 2, x plus 1, over my original denominator, x plus 2, and that equals, again, my original numerator now is x minus 1. My two new numerators that I'm adding to it or multiplying by it are x plus 2, x plus 1, and that's over x plus 1. Okay, so now you cancel. Okay, the x plus 2 and the x plus 1 cancels in that one. Just the x plus 2's cancel there, and just the x plus 1's cancel. Okay, if for some reason your denominators don't cancel, then you multiplied incorrectly. You either forgot a term, you forgot a factor, or something like that. Okay, so just be very careful with that. That's why I'm having you write this out and showing your work there, because it helps you see what actually cancels off. Okay, so only thing left in the first term was x minus 1. You can just rewrite it. Here you had the 2x and the x plus 1. Remember, these are being multiplied, so you have to distribute there. So you'd have 2x squared plus 2x. And that equals, now you have a binomial times a binomial, which means it's everybody's favorite. You get FOIL, x times x is x squared, x times 2 positive 2x, negative 1 times x is negative 1x, negative 1 times 2 is negative 2. Combine the middle terms there, so you get x squared plus x minus 2. Okay, kind of looks a little bit confusing still, a little bit messy, but let's clean it up. All right, on the left side, you've got 2x squared. I'm going to write that first. 2x and x make 3x minus 1. And then on the right side, you've got your x squared plus x minus 2. This is a quadratic equation. You have to get everything to one side. Okay, so I'm going to move everything over to the left side. So I'm going to subtract the x squared and the x. And I'm going to add the 2 over. That leaves me with a 0 on the right side. 2x squared minus x squared is just 1x squared. 3x minus x is 2x. And negative 1 plus 2 is 1. Okay? And you know what I forgot to do? I feel like an idiot. Oh my gosh. Right away, I should have stated my restrictions up here. X cannot equal negative 2 or negative 1. Don't make that mistake. Do that right away. That's my fault. Bad, Mr. Kempson. Okay, so x squared plus 2x plus 1, you factor that, you get x plus 1 and x plus 1 equal to 0, which means that x equals negative 1. But uh-oh, that's one of our restrictions. Now, since this is the only solution and it's a restriction, it's not extraneous. Extraneous means extra. That means there's one that works. There isn't one that works. So this is a no solution. We did all this work for a no solution, okay? But that's fine. Again, if you would have two different answers, one of them works and one of them is a restriction, then the one that's a restriction is extraneous. But because you only have one answer and it's a restriction, that's what makes it a no solution, okay? So on your own, here's one to try. Okay, you've got x plus 1, x plus 4, and x plus 4. Okay, so you're going to have to multiply. You only have to multiply by x plus 4 one time. Okay, you don't have to multiply it by it twice. All right, go ahead and try it. Otherwise, here is the work and the solution. Those were the restrictions. Our solution doesn't interfere with our restrictions, so we're fine.